Is it possible to measure the temperature of the wavelength itself? Or can the heat generated when waves collide with atoms or molecules be measured as temperature? In general, it is difficult to measure the temperature of a wavelength itself. Wavelength is a property of light or electromagnetic radiation, and it is not possible to accurately determine the temperature from wavelength alone. To use wavelength for temperature measurement, it is generally necessary to consider the complex spectral analysis and the emission characteristics of the object, such as Planck's law. This method is used in a variety of environments, such as stars, planetary atmospheres, and object surfaces. The common method is to measure the intensity of light emitted by wavelength, and to estimate the temperature by analyzing this information. In addition, if heat is generated when a wavelength interacts with atoms or molecules, the heat can be used to measure the temperature. This is a form of spectroscopic measurement, which is used to determine the temperature and chemical composition by analyzing specific lines in atomic or molecular spectra. These methods are applied in a variety of fields, such as scientific research, chemistry, astronomy, and environmental monitoring. Therefore, it is difficult to directly measure the temperature of a wavelength itself, and temperature measurement through wavelength requires more complex analysis and interaction processes. The energy of an electron depends on its state and position. Electrons have quantized energy states according to quantum mechanics. The energy of an electron is typically calculated using the following equation. E equals 13.6 electron volts, n squared, where E is the energy of the electron, and n is the principal quantum number. EV is the unit of energy called electron volt. The energy values given in the above equation correspond to the electron energies of hydrogen atoms, and these values may be different for other atoms or ions. For example, an electron in the ground state of a hydrogen atom, n equals 1, has an energy of 13.6 electron volts. This energy can be interpreted as the electrical interaction energy between the electron and the nucleus of the hydrogen atom. When the state or position of an electron changes, its energy can also change, and the electron can move to different energy states within the atom. Electron energy plays an important role in chemistry and physics, and it is used to understand the electronic structure of atoms and molecules and chemical reactions. Additional details. The term principal quantum number could be defined. The principal quantum number, n, is a quantum number that describes the size and shape of an electron orbital. The concept of ground state could be explained. The ground state is the lowest energy state of an atom or molecule. The concept of excited state could be explained. An excited state is a higher energy state of an atom or molecule that is achieved when an electron absorbs energy.